Okay, so coming back a little bit closer to home now, and this is the hydrogen appliance that we've produced as a prototype. This is the team that have produced them at Worcester, quite a young, dynamic team, really, which I think is important because this could end up being the technology of their generation. I think sometimes they look upon this prototype as perhaps the most boring prototype ever because it just looks like a gas boiler, but that's the point of hyperheat really, is to look at trying to produce prototype appliances that we could literally use in our homes today. And this photo was actually taken quite some time ago, and since then the appliance has moved out of the lab, as it were, and out into field trials. This is a picture here of the boiler installed up at the Spade Adam site in Northumberland, where a lot of this test work is going on. And you can see it looks like a boiler, it just, in somebody's kitchen here, and, is functioning just like a normal appliance would. Now, all of this sounds quite straightforward, of course, but there are some significant challenges when you come to look at appliances to run on 100% hydrogen. The flame speed is quite challenging because the flame speed is a lot quicker than it is for natural gas. And so a lot of the engineering that has gone in to make the new boiler is really around engineering any kind of risks that flame speed presents for us. I think some of the other characteristics really of hydrogen, calorific value is quite a bit lower than where natural gas is currently, and I think a lot of people think, well, is that not a significant barrier then really? Because if we've got a big difference there, how are we going to get enough gas through the pipe? But actually, when you come to different gases, what's important is the wobby. And the wobby is made up of the calorific value and the density. And because the density is also a lot lower, there's a kind of cancelling out effect here. And so the wobby ends up just slightly lower than where we are with natural gas currently. I think flame temperature was also a concern when we started this project because NOx emissions can be affected by flame temperature, and that was something that we were very conscious of. But as it turned out, that didn't end up being the case. And when we moved to premix burner technology, and that's the type of burner that you might have perhaps in your boiler at home already, then the NOx emissions actually came down very significantly. And to begin with, we didn't really fully understand this, but Bosch has worked with a number of universities to really look at the science behind this. And it turns out it's to do with the flame speed again, and the fact that the nitrogen that's in the air for combustion is not within that hot flame for very long because the flame is so quick and so short. And so that was a welcome, kind of boost to the project, and something that definitely wasn't anticipated originally.